In this video, we will take a look at some special series, which include series that can be solved using the method of difference and the infinite series. In some summations, although there are several terms within the summation, we do not need to split the terms up into individual summations. This is because it will still not be solvable as we do not have the formula for the individual terms. Instead, we notice that some of these terms are actually consecutive terms. For example, we can have summation of ur minus 1, or the summation of 1 over r minus 3 over r plus 2r minus 1. In these cases, we can make use of the method of difference because we know that the subsequent terms will cancel each other out. For example, in this first term over here, if we expand it in a vertical way, we will have u1 minus u0 as the first term plus u2 minus u1 for the second term, u3 minus u2 for the third term, and so on, all the way until our very last term, un minus 1. And what we can observe is the u1s will cancel out nicely, u2 as well, and eventually un minus 1 and un minus 1. And therefore, everything that is in between this pair and this pair will cancel out nicely, and what we are left with will be un and u0. And thus, this summation can be simplified into just un minus u0. Likewise, in this second example, we can expand it vertically to write 1 over 3 minus 3 over 2 plus 2 over 1 as the first term when we substitute r equals to 2 in, plus the second term, which is 1 over 4 minus 3 over 3 plus 2 over 2. And we can have a third term of 1 over 5 minus 3 over 4 plus 2 over 3, and so on. And if we write down the last two terms, we will have 1 over n minus 3 over n minus 1 plus 2 over n minus 2, and finally 1 over n plus 1 minus 3 over n plus 2 over n minus 1. And what we can observe now is that if we look at the terms 1/3 minus 3/3 and plus 2/3, they will cancel out nicely for us. Likewise, every term that is going to be in between 1/3 minus 3/3, 2/3, and also 1 over n minus 1 minus 3 over n minus 1 plus 2 over n minus 1 will cancel out nicely for us. And therefore, what we are left with are these three terms over here and these three terms over here, which gives us negative 3 over 2 plus 2 over 1 plus 2 over 2 plus 1 over n plus 1 over n plus 1 minus 3 over n. And of course, we can simplify this to get the final answer. In example 1, we are asked to solve for this summation, and we are given the clue that this term within the summation can be written as these three terms. And note that the coefficients are 1, minus 2, and 1, which add up to be 0. So this gives us a definite clue that we need to make use of the method of difference to solve this summation. So we can say that we have n summation r equals to 1 of r squared plus r minus 1 over r plus 2 factorial is going to be equals to the summation of 1 over r factorial minus 2 over r plus 1 factorial plus 1 over r plus 2 factorial. And we can expand it vertically. When r equals to 1, we have 1 over 1 factorial minus 2 over 2 factorial plus 1 over 3 factorial plus 1 over 2 factorial minus 2 over 3 factorial plus 1 over 4 factorial plus 1 over 3 factorial minus 2 over 4 factorial plus 1 over 5 factorial. And we proceed to write down the last two terms. When r is equals to n minus 1, we get 1 over n minus 1 factorial minus 2 over n factorial plus 1 over n plus 1 factorial, and finally 1 over n factorial minus 2 over n plus 1 factorial minus 1 over n plus 2 factorial. Now these are all the terms after expansion, and if we try to look out for the groups of numbers to cancel, it will be these three terms over here, and therefore the final three terms here, and everything in between goes away, and thus we are left with these three terms here and these three terms here, which will give us 1 minus 1 plus half plus 1 over n plus 1 factorial plus 1 over n plus 2 factorial minus 2 over n plus 1 factorial. And if we evaluate everything, it becomes half minus 1 over n plus 1 factorial plus 1 over n plus 2 factorial. In a series, if we do not stop the summation at n terms, but instead we sum all the possible terms, it is called a sum to infinity. So instead of Sn, we now have S infinity. In certain series, we can get a finite value for the sum to infinity. For example, if we sum half to the power of r, we can show that the sum of this infinite series is 1. And this means that the sum to infinity exists and the series is convergent. In other cases, for example, the sum of 2 to the power of r, the terms in the series become larger and larger as r increases, and there will not be a sum to infinity. This means that the series is divergent. To calculate the sum to infinity of a series, what we have to do is to first find the sum of n terms, then substitute n as infinity by taking the limit as n tends to infinity. So for example, we will find out what is Sn, then S infinity will be the same as taking the limit of n becoming infinity of Sn. So for example, if now we have Sn equals to 1 plus 1 over n minus 1, its sum to infinity will be taking the limit of n going towards infinity of 1 plus 1 over n minus 1, which becomes 1, and therefore we know that this series is convergent. Likewise, if Sn is equals to n, then S infinity will tend towards infinity, and therefore this is a divergent series. From example 1, we have determined the sum of n terms of the particular series, summation of r equals to 1 to n of r squared plus r minus 1 over r plus 2 factorial. We know that it is equals to half minus 1 over n plus 1 factorial plus 1 over n plus 2 factorial. Now we are asked whether the sum to infinity of this same series is convergent or divergent. And that means we have to find out the sum to infinity. So let's try to find out the sum to infinity. So I have this series. It is the same as writing the limit of n tends to infinity of the sum to n terms r equals to 1 to n of r squared plus r minus 1 over r plus 2 factorial, which is also the same as taking the limit of n tends to infinity, half minus 1 over n plus 1 factorial plus 1 over n plus 2 factorial. Now when we substitute n as infinity into this term, half remains. This second term goes to 0 because the denominator is now infinity. And this term as well, the denominator becomes infinity, therefore this term goes to 0. And thus, this sum to infinity becomes half, which is a finite value, and therefore we say that the series is convergent.